Hello. So today we are going to cover the full Norton circuit. This is a presentation by Kirsten and Marissa. So a little bit of background. What is Norton's theorem? Norton's theorem states that it's possible to simplify any linear circuit, no matter how complex, to an equivalent circuit with just a single current source and parallel resistance connected to a load. Just as with Thevenin's theorem, the qualification of linear is identical to that found in the superposition theorem. All underlying equations must be linear. Okay, so a really critical part of what we're going to be covering today involves source transformations, and that allows us to get from like a Thevenin to a Norton. And so a source transformation is basically just an application of Ohm's law, V equals IR, as shown at the bottom. Utilization of the principles of a source transformation allow for easy conversion from the Thevenin equivalent circuit to a Norton equivalent, demonstrating the linear properties of the system. The principle at hand is, as stated, a load resistance across the AB terminal must experience the same current and voltage drop for both configurations. It is important to note the key differences between the two relevant circuits at hand. While they both employ the same equivalent resistance, the constant which proves linearity of the system. A Thevenin equivalent circuit involves the total voltage of the circuit in series with Req, whereas the Norton equivalent involves a total current of the circuit of interest in parallel with Req. This is how a source transformation works. Let's look at an example and the multitude of ways to approach such problems. So this is a simple example of a source transformation. The important thing to note is that this voltage source is in series with this resistor, and then during the source transformation we use V equals IR to find a equivalent current source that is in parallel with the same resistor. So we take these values here and we apply them to our equation. So we have, So we have 2 volts is equal to I times 1 ohm. And so you get I equals 2 volts over 1 ohm is equal to 2 amps. And so this value is 2 amps, and that's our source transformation.
Like, do like a fast forward through the erasing, like we're like, and so how Kirsten had gone over the whole Norton equivalent circuit and everything, we're going to actually try a harder example at this point. So as Kirsten just discussed about a source transformation, that's actually the first thing that we're going to be doing between these two elements in our circuit, and that allows us to change this source, this voltage source, into a current source. And so by doing that, you can use Ohm's law, which is V equals IR, and by doing that, you have a voltage of 10 volts, and it's equal to an I, which you're trying to find, and then your 5 ohms. So then your I is then 10 volts over 5 ohms, which then will give you your 2 amps. So you're going to use that number. So once we redraw it, we also have to take into consideration that when you do a source transformation, that resistor that is in series with the source, the voltage source, it actually becomes in parallel with the current source. And so when we redraw the circuit, it turns into this. Awesome. And also know that although we did a source transformation, this resistor had no change to its value at all. The only thing that really changed was the source itself. And so going forward from this point, the next way you can solve it is you can actually now combine these two sources and also combine these two resistors that are in parallel. So that's what we're going to do. We're going to combine this one, as well as this one, and this one. So since they're both sources of current, it's going to be 2 amps plus 2 amps, which is 4 amps. And then your resistors are in parallel, so you have 5 ohms in parallel with 20 ohms, which then will give you 5 times 20 over 5 plus 20, which is 100 over 25, which is 4 ohms. So when you take that, you're going to now put it into a new circuit, because we're breaking it down. We're going to make it a lot easier. We're going to make it 6 ohm resistor at the top, and that will now start playing a part. Because what you're originally trying to find is just a way to break this down into the Norton equivalent, which takes these into consideration, and this plays a huge part as well. So I'm going to erase everything. It's also important to remember that between the Norton equivalents and the Thevenin equivalent circuits, there's one thing that is constant for sure, and that is the R Thevenin, because R Thevenin is equal to R Norton. And so I feel more comfortable finding the R Thevenin and applying it. So in that case, we're going to do a second source transformation between these two components. So we're going to use the same V equals IR. Your V is what you're trying to find. Your I is your 4 amps. Your R is your 4 ohms. And so your V, you multiply those together, is 16 volts. And then you use this into a new circuit that you can draw. Moving forward, now you can find the R Thevenin, which is basically R equivalent. At this point, it is 2 resistors in series, so it's 4 ohms plus 6 ohms is equal 10 ohms. And that equals your R equivalent, RTH, R Norton, however you want to look at it. So then we're going to redraw the circuit. Again, you are going to do a lovely source transformation because what you have right here is your Thevenin. When we don't want the Thevenin, we're looking for the Norton. So in order to go to the Norton, we're going to yet again do another source transformation doing this. So it's the same V equals IR. Your V is 16, your I is unknown, and your R is now this 10 ohms. So then now you have 16 volts over 10 ohms is now equal to 1.6 amps. And this is equal to your I Norton, which is very important. So now we're going to take this circuit and draw it over here as your final Norton equivalent as a current source going into a parallel resistor, and then you have your terminals A and B. This is your REQ, which is now your 10 ohms, and this right here is your source that we just found, which is 1.6 amps, and that is your Norton equivalent. Oh, such a painting. Look at this.
I know, I see it. No, trust me. Wow. Welcome to our art class. Next week we'll be teaching you how to do
Waves in motion.
modern art
Circuitry.
glass cleaner. Expo Bright Sticks. This is not an ad.
Expo.
Unless Expo would like to pay me. Then it's an ad.
Follow my YouTube. Subscribe.
Please like the video below. Subscribe. Thank you.
So here you can see that the difference between the original circuit is right here, and the original circuit itself had 2 sources, which seemed terrifying. Trust me, I know. But using source transformations are a huge resource that should be applied in when you do things like this. You can also use superposition, whatever is easier. But also, the way that I did it was a source transformation, and it helped a lot where you got this original, and now this Norton equivalent right here, when you apply all the steps, is there. And you have a very simplified circuit. You have only 1 source and 1 resistor compared to 2 sources right here and 3 resistors. So, hope it helped. It done did a thing.
It done did a thing.